Okay, welcome everybody. In this video, we are going to talk about how we could find the derivative of trigonometric functions, just the way we spoke about finding derivatives in the previous examples for various functions like the product function, the rational functions. Today we are talking about the derivative of trigonometric functions. Okay, let's get started. So, assume that we have a function which is y is equals to minus 10x plus 3 cos x. Okay, let's say we have that function, and it's of course a trigonometric function because it's containing cos. So the way to find its derivative is simple. It's just we are going to find y prime. Okay, the derivative of minus 10x will be would just be minus 10. We already know that. And now the derivative of this part will just be plus 3 plus 3. So the derivative of cos x is just minus sin x. It's just minus sin x. Okay, so that eventually gives us minus 10 minus 3 sin x. Okay, so the derivative of this function here is going to be this. Of course, that's the first derivative. You could as well continue to find the second derivative, the third derivative as well. Okay, we take another example. Let's say we take this one now. Let's say we have a function which is y is equals to x squared times cos x. Okay, so we have that one, and now we want to find the derivative, that's the y prime. Okay, so how are we going to do it? We are going to use the product function, the product rule I mean, because we have two functions which is x squared times cos x. Okay, so we are going to use the product rule for this derivative. Okay, so the way we are going to do it is first we're going to find the derivative of x squared, and then we multiply it with cos x. We just take the cos x, then what's gonna next, we add it to. So this time we are going to take okay, sorry, here I forgot to add the derivative sign or the differentiation sign. And then next I'm going to pick x squared and then multiply it with the derivative of cos x. The derivative of cos x, okay? That's the way we do. That's the way we learned. Even I showed you in the video where I'm talking about finding derivative of product functions, or how to apply the product rule. So I'm gonna put the link here above so you can go and watch that video if you didn't understand how to find or how to use the product rule. Okay, now we can find our y prime. So if the derivative of x squared is just 2x, and then we are going to multiply it with cos x, and then I'm going to add it to x squared, just pick it. The derivative of cos x is minus sin x, okay? So it becomes out to be a simple thing, okay? So eventually what you can have is this. Our derivative will be 2x cos x. Now here, instead of having plus, we can have minus, since we have a minus there, minus x squared sine x. Okay, so that's the derivative of our function. That's the derivative, the first derivative, or the y prime of our function, this function. Okay, so what you need to understand here is is you need to master the the derivatives of trigonometric functions. For example, if you want to find the derivative of cos x, you need to master them at least. They are available. Cos x. Okay, what will it give you when you differentiate cos x? What it will give you is minus sine x. Okay, and the derivative of cos x d all over dx of sine x will be what? Would be now cos x, and okay, that is what you need to master. And the derivative of the derivative of what? The d all over dx of tan x gives you what? 6 squared x. Okay, so that is what you need to understand. Of course, there are another at least 3 more trigonometric functions, but once you understand the derivative of each trigonometric function, you can easily find the derivative for any function that carries a trigonometric functions. Okay, having said that, I'm gonna conclude this video, and in the next video I'm going to talk about how we could find the derivative of inverse trigonometric functions, so you can watch it as well, so that you can have full understanding of derivatives. Thank you. If you didn't subscribe, please consider subscribing. Thank you.